Let's get started. This is Pipelines in Jenkins X. My name is Andrew Baer. I'm an engineer at CloudBees, long time contributor to Jenkins, Hudson, et cetera. I created Jenkins Declarative Pipeline, but these days I'm working on Jenkins X Pipeline and Tekton. Now, a quick poll. Who here had heard of Jenkins X before this week? All right, that's good. Who here has used Jenkins X? Cool, that's fine. I'm not criticizing you for not having used it yet, don't worry. So I'm gonna move very quickly through what Jenkins X and Tekton are, because I'm not here to talk about the opinionated pipelines, about promotion and environments. I'm here specifically to talk about how pipelines in Jenkins X work and how you write them. But just quickly, in case you didn't know and walked into the wrong room, Jenkins X is Kubernetes native CI and CD for building traditional and modern cloud-native workloads. Provides you with environments, GitOps for promotion, and a lot more. Who's heard of Tekton? All right, I will not be talking in any detail about Tekton here because for Jenkins X, Tekton is an implementation detail. Tekton is how we run pipelines in Jenkins X serverless. It is not something that the user ever needs to worry about. It's just a really fantastic pipeline execution engine. It's part of the CDF and started by Google, contributors in many other places, including myself. I love it. It's a great building block, but it's not something that a user of Jenkins X needs to ever think about. So we won't talk any more about it than that. So how do Jenkins X pipelines work? A quick note. There are two ways to run pipelines in Jenkins X. There's what I'm going to be talking about here, serverless Jenkins X pipelines, and then there's static masters, which use traditional Jenkins files. I'm just going to be talking about Jenkins X pipelines or serverless, et cetera. That's the direction that's got the most new stuff going on in it. It's the new and exciting area both to work on and I hope to use. And if there's already a lot of resources out there for learning about traditional Jenkins files, traditional Jenkins pipeline. So a quick summary of the life cycle of a Jenkins X pipeline. First, a pull request is opened, a change is made to the master branch, or someone manually kicks it off. Generally, it'll be via reacting to a new git commit or GitOps, ChatOps behavior. Jenkins X is notified. Jenkins X then takes a look at the repository that it's been asked to build, looks to see if there's a pipeline definition in there or what build pack it should use, and I will explain this in more detail in a little bit. We generate the CRDs, custom resource definitions, it's Kubernetes lingo, for the Tekton pipelines, and Tekton handles the actual execution. While the actual pipeline is executing, Jenkins X monitors it, tracking its status, logging through completion, et cetera. And go into a little more detail on some of those things later. There are two main types of pipelines in Jenkins X. Release and pull request. There's also feature, but no one's really sure what to do with that one. I've never actually found a reason to use it, but if you've got long-running feature branches, it may be of use to you. But I'm just going to use these two examples here. The release pipeline runs on every commit to master. A new unique release version is generated. The commit is tagged. The tag is pushed back to the origin repository so that you can reproduce it, see what was built, et cetera. Pull request builds, pull request pipelines are run, unsurprisingly given the name, on every pull request to the repository. There is still a distinct version for each PR, for each pipeline run, but we're not tagging anything. It's a throwaway snapshot type version. And while a pipeline is running and after it's complete, you obviously want to know what's going on with it. It's all well and good to have a pipeline run, but what's the point if you can't look at logs? At least for me, I get a little obsessive about that. The main way in Jenkins X currently to look at logs is to use a Jenkins X command line step, JX get build logs. You can also get more of a higher level perspective on the status of your pipelines via JX get activity, which will show you the stages and steps that are running in a pipeline, their duration, their status, et cetera. And of course, when a pipeline completes, when it's a pull request pipeline, the pull request will have its status updated with the results of the pipeline, because otherwise, what's the point? So those are the high-level summary of how a Jenkins X pipeline works. Now let's take a look really quickly at the basic concepts in Jenkins X pipeline. Who here is already familiar with Jenkins pipeline? And how about declarative pipeline in Jenkins? So I will admit there's a lot of conceptual overlap here, probably because I've worked on both of them. And also because it's a lot of the same core concepts you're going to see in a lot of CI and CD systems. The two main concepts are steps and stages. A step is a command that will run on a container. Each step is in a separate container, which took me a while to get used to from the Jenkins world, where you can say, here's my agent, run this series of steps on that agent. But despite the fact that each step is running on a separate container, you still have a shared workspace. You still have access to the same files that have been manipulated, et cetera, by your previous steps. So it's not that each step is happening in a completely new machine with no context from the earlier steps. When a step fails, no more steps will be run. We have plans to have behavior like post in declarative. We don't have that yet. This is still pretty early stuff. And step names must be unique within a stage. We try to utilize names as a way to do reporting and overriding capabilities, and so we're requiring that you have names and that they be unique. And what's a stage? Well, it's a unit of work in a pipeline. It's one or more steps, or it can contain nested stages. Again, very similar to declarative pipeline. Each stage that has steps gets its own pod, so that all of the steps are running in the same pod. There's no delay between spinning up the container for one step and spinning up the container for the next step in the same stage, because it's running in the same pod. But that also means that there is a little bit of a potential delay between stages, because you have to spin up a new pod. It's still a lot less than waiting for a new EC2 agent to provision in Jenkins, so I think it's okay. And just as the same workspace is available for all steps within a stage, the workspace is copied from one stage's pod to the next, so you still have access to the same files that you've changed, as the source checkout, any artifacts you've built. You don't need to worry about stashing artifacts or copying them somewhere where you can then get them in a later stage, despite the fact that it's in a new pod. So, yeah, basic concepts, et cetera. Now, how do you define a pipeline in Jenkins X? There are three main ways to define a pipeline. Oh, and by the way, all of these slides will be available. I didn't actually finish them until yesterday, because of course not, you can always fret. But there are a bunch of links to examples in here. There's a repo I've got up that has all those examples in them. This will be available to everybody within an hour or so, hopefully, of the end of this, assuming I can find the right person to email it to. So don't worry too much about having to take pictures. I know how stressful that can be. But yeah, so there are three main ways to define your pipeline. First is you don't have to do anything. Jenkins X has the concept of build packs, which are standard opinionated pipelines for languages and use cases that are built in to Jenkins X. And if you do nothing, if you just import a new project or create a quick start in Jenkins X, Jenkins X will be able to look at it when it's time to run a pipeline and say, oh, there's no configuration here, but I think I can figure out what language is right here, and so figure out what the right build pack is for that language. So that for a lot of things, if you're using the Jenkins X workflow, you don't have to do anything. It just works. But if you're using something that, like the language detection doesn't work for you, or you want to be able to make changes to the behavior that the build pack provides, you can create a Jenkins X YAML file in the root of your repository, and you can specify exactly which build pack you want to use. You can override, add to, remove steps from the build pack pipeline. And finally, you can do a fully defined pipeline in your Jenkins X YAML, where you're not doing anything with build packs, you're explicitly specifying everything that's going to happen in your pipeline. Most of the time, like the overwhelming majority of the time, if you're using Jenkins X, you're probably going to be in one of those first two categories. But if you're not deploying software directly, like Jenkins X, our own repositories where we're building artifacts that we're releasing, but we're not deploying, the build packs aren't great fits for us, so we write our own pipelines. So a little bit more about build packs. Like I said, they're standard, they're opinionated, they're maintained, they're extensible so that you can avoid repeating common pipeline configuration. There's a lot of things in Jenkins X Pipelines that one of the major intents we have is to avoid copy pasting so that you can do as little redundant information as possible. The build packs, like I said, are used when you're creating a project from the quick start. They're used in static Jenkins masters as well. The Jenkins file is generated from the build pack. They inherit from each other. We've got default build packs are all available publicly. You can also, though I don't honestly remember exactly how you do this, define your own custom build packs and add that to your Jenkins X instance. A small bit of potential confusion is that build packs don't have stages, they have life cycles. This is partially different generations of design, but it's also that the life cycles are predefined life cycles of steps, predefined sets of steps that are run in a consistent order. Setup always runs before build. Promote always runs after build, etc. They're similar to stages in that they're overridable, they're extendable. They don't have the full range of configuration that you can have with stages, but all life cycles run in the same pod. So there is no delay, even if it's just 15 to 20 seconds of spinning up the pod for the next life cycle. So that's a thing. And Jenkins X YAML. So as you probably can guess from the name, it's a YAML file. As I said, it lives in the root of your project repository. And you can use it for setting the build pack to use or inherit from, overriding or extending that build pack, and for defining the full pipeline. So that's the one file that you should have to worry about in your repository for your Jenkins X pipelines. I mean, besides, your makefile or pom.xml or charts, etc. But now let's take a look at overriding build packs. This is most likely going to be the first thing that you encounter, the first thing you want to be able to do with Jenkins X Pipelines that requires you to actually do anything. Among the things you can do via overriding build packs, you can add steps to the standard build pack as well as removing them. You could change the behavior of existing steps. You can override what's happening in the promote build step to do something different. You can modify the default container configuration for your steps. You can change the image that's being used for a particular step. And you can also add environment variables, etc. As I said, the way that you do this is that you add a Jenkins X YAML file to your repository, and you add your override configuration. Now we'll take a look at what that actually means. So I'm moving down through the example here, and I couldn't put the whole thing in here because it's YAML, and so it's really long, so there's a bunch of screenshots. And again, this is all in a repository. The slides will be shared. I promise. So environment variables are very often one of the first things you want to be able to change in your pipeline. You want something that Jenkins X is doing by default, or maybe that isn't quite right, or maybe there's an environment variable your Maven build needs that otherwise you don't need to make changes to the standard pipeline. So you can add or override environment variables. There is no way to remove ones, but it's standard Kubernetes environment variable syntax. There's a couple places in more advanced configuration where we just fall back on standard Kubernetes syntax. But if you look at lasers, the basic syntax is just simple name value. It's what you would expect. But you can also take advantage of some of Kubernetes' more complex and advanced environment variable support, so that you can pull in environment variables from secrets, from Kubernetes secrets or other sources. And you can define environment variables on individual pipelines, or as I'm doing here, by putting it under pipeline config, which lives at the top level of your Jenkins X YAML. These environment variables will be used for all the pipelines, for both pull request and release. You can also define environment variables per stage, but we'll get to that later. Now, the examples I've got here are actually from my colleague Oscar Medina's demo of integrating with honeycomb.io for observability in a Jenkins X pipeline. And so he needs to do something like, okay, before we run any of the life cycles or stages, we need to download a binary and set it up so that we can do the instrumentation on our pipeline execution. So by populating the setup lifecycle, we're able to say, okay, this stuff runs before any of the built-in steps, before anything in the built-in pipeline normally would. We don't have to know what those steps are called. We don't have to think about what they do. Setup always lets you just say, oh yeah, run this first. And it's just a list of steps, and yeah, they run before anything else. Now, if you need to make changes within an individual life cycle, if you need to add a step that runs before or after an existing step, this is how you would do it. You specify the pipeline name, stage or life cycle name, and a step name so that it knows, okay, here's where in the pipeline I need to go to add something. You can add one step by using step, or multiple steps by using steps, along with specifying the type. In this case, it's either before, in the first case, or after. So that here we're going to say that in the pull request pipeline, before we run the npm install step, let's put in this other step. Let's run the honeycomb, let's echo out the time that we've got so that we're able to do the instrumentation. And then after the npm install step, let's add another step that actually calls the honeycomb instrumentation and uses it. Sorry, the font size is a little small on my screen, which I had to duck over. I apologize. But like I mentioned, I want to not repeat yourself. And there's definitely some vulnerability to repeating yourself there. If you've got the same behavior that you want to change in both your pull request and release pipeline, do you really have to copy and paste it? No, you don't. If you don't specify a pipeline name, and you just specify the stage or life cycle and the step name, then we'll look for that stage or life cycle in every pipeline, and look for that step name in that stage or life cycle, and make the changes around that step in all places. You can even take that further by removing the stage name, at which point it will look for any case of a step named npm test and try to add these new steps before and after them. Like I said, the goal here is to avoid copy-paste that is excessive. Now, sometimes this is kind of the correlation to the setup lifecycle that I mentioned. This is the ability to just say, let me run steps before or after the entire lifecycle. I know that I need to do this after build finishes or before promote runs. And I don't need to care about what the individual steps at the beginning or end of that lifecycle are named. If you just specify the stage and or pipeline and steps to add, along with the type of before or after, it just adds them before or after the first or last as appropriate step within that stage. So there's just a little bit of cheats here and there to make it easy to manipulate the pipeline without having to know all the details of what's going on in it or remember that something might have changed, etc. You can also replace or remove existing steps. My example here is, well, it makes the actual pipeline not work because I had to wipe out a step that actually did something meaningful. But if you use the type replace, it will kind of do what you'd think. It looks for the same step, same combination of name of step, name of stage, name of pipeline optionally, and takes out the step by that name that currently exists and replace it with one you specified. And if you don't specify a step to replace, if you do type after along with the step name, stage name, et cetera, it just removes that step from the pipeline completely. All right, now full pipelines in Jenkins X YAML. As I said, I don't know how often you're going to need this, but it's a good tool to have available for you. Not all pipelines fit the standard Jenkins X lifecycle. I would assume that most you would use in Jenkins X will, that you're building something that you're going to deploy via Helm chart and a preview environment, et cetera. But maybe you're building a library that other applications depend on. Maybe you're not building a container image that you're deploying. And there, being able to specify your full pipeline like you can in Jenkins is very handy. We use this approach extensively in Jenkins X's own repositories, as I mentioned. It gets a little bit less useful if you're repeating yourself. If you are trying to do the same thing across multiple repositories, you're best off with a build pack, maybe a custom build pack. But as of now, there isn't an easy way to just share or load bits of a pipeline in a Jenkins X YAML from across multiple repositories, but that's something that we're working on. So how is a pipeline structured? One or more stages, because obviously we got to do something. At least one of those stages has to not contain nested stages, but actually contain steps, because again, we actually have to do something. And you've got to specify an agent, as in what image should be used for the steps to run on at some point, at least at the top level or on each individual stage. And how do you define a stage? Like I said earlier about step names, stage names also need to be unique across your pipeline. Across multiple pipelines, whatever, who cares? But within a single pipeline, the stage names have to be unique. Stages can contain one and only one of steps, which would be a list of steps, oddly enough. Stages, which is a list of nested sequential stages, which will run one after another. You can use that for defining common configuration that you inherit, so again, you don't have to copy, paste, and repeat yourself. Or parallel. Parallel allows you to, well, kind of do what it says, run multiple stages at the same time. And besides just those three things, you can configure things like environment variables, agent, and container options, which I'll get into a little more detail in a bit, on your stages, so that you can define, say, here are the things that should be configured for every step running in this stage, or every stage that's nested within this stage. Which of course means stage configuration is inherited by nested stages. So agent is a little bit silly in that I kind of prematurely optimized here from declarative, in that right now it's always agent and image. Because right now all you can do is run on a container, and so you can specify the image to use for the containers. We do intend to eventually have support for running on individual steps and possibly stages on, say, a Mac or a static agent somewhere that is really beefy and you don't want to wait to spin up. We're not there yet, so right now, yeah, it was a little premature optimization. I apologize. The image can either be a fully qualified Docker image with tags, so foo/bar :latest, or gcr.io/JenkinsXIO/ blah blah blah, or it could be an alias for a Jenkins X pod template. Jenkins X includes a set of builder images that already have Jenkins X and the relevant tools for building a specific build pack or language baked in, and we've got aliases for those. So if you specify Go as your image, you're going to get the Jenkins X Go builder, the version that is currently available in your version stream. Which I just find really handy because then you don't have to worry about the versioning, you don't have to worry about the fully qualified URL. You know it's going to have everything that Jenkins X is going to need to run individual steps on it. And you don't have to worry about maintaining your image, which is quite nice, I think. Agents can be specified in a lot of places. You can specify them for the whole project at the top level like I am here. You can specify them on the pull request or release pipeline. You can specify them on individual stages, or you can even specify them on individual steps. And if you don't specify an agent on a step, then it's going to use whatever's specified on the stage. If there's nothing specified there, the pipeline, et cetera. Now, what exactly are you configuring for a step? Like I said, it's a command that runs on a container as part of a sequence of steps within a stage. Image, working directory, and environment variables for the steps can be configured per step or inherited, like I was just talking about. Then you can specify the command to run and arguments. Additionally, we have a special step type, loop, which allows you to specify a list of values and run a set of steps for each of those values. So it'll set an environment variable. So you could do browser, Chrome, Safari, Edge, whatever, and you would run the same set of steps for each of those variable values. Kind of like the Jenkins Matrix project, or the to be revealed at 4:15 today in this same room, matrix syntax for declarative pipeline. Hi, Liam. Now, I mentioned container configuration, or what we call container options. Out of the box, you're just going to get the default configuration for your container. So you may not have resource limits and requests set. You wouldn't have volumes mounted other than what Jenkins X does by default. You may need to want more configuration of your containers than just what comes out of the box. So via options, which can be specified at the top level of a pipeline or at a stage level, you can configure the container options. Again, this is Kubernetes container syntax. It's the exact same syntax you'd have in any other case where you're configuring containers. We don't let you configure a few of the fields, name, image, command, and arguments, because that would just create a lot of confusion since you're already configuring that for steps. But using this, you can specify your resource requests and limits, which is an area we've found heavy usage for. Volume mounts, anything else. You can specify this at pipeline or stage level, and they're inherited and merged, so that if you have resource limits and requests defined at the top level of your pipeline, but one of your stages also needs to mount some volume, you can just specify the volume mount in the individual stage, and it'll still pick up the resource configuration from higher up. And continuing with my mildly creepy obsession with not repeating yourself, there's the concept of the default pipeline. I eventually got annoyed at the fact that, wait, so I'm specifying these pipelines, and their pull requests in the release pipeline are pretty much the same. They're like 90% the same. Why am I having to copy and paste all this? And so we created the concept of the default pipeline. It lives at the same level as pull request or release, except it's the default. If you don't have an explicitly specified pull request or release pipeline in your Jenkins X YAML, it'll use the default pipeline. And then you can do overrides the same way you can with build packs, so that you can say, all right, here's my release pipeline, here's my default pipeline. It's basically the same as my pull request pipeline. My release pipeline does a little more. And then you can actually specify how they differ the same way you would as if you were editing, overriding from a build pack. So it's just the same syntax. It's just a little stupider because it's kind of a janky example. But yeah, here I'm overriding the agent that is being used, the agent and container options that are being used for the pull request pipeline, as well as adding a step to the release pipeline to, run a release. So again, these examples are online and links, et cetera, et cetera. A few other bells and whistles around interacting with, writing, and using Jenkins X pipelines. This one's really handy, I find. It's a Jenkins X step. It's part of the Jenkins X binary. If you run jx step syntax validate pipeline in your repository's root directory, it will validate your Jenkins X YAML and make sure it's actually a legitimate and legal pipeline. Because otherwise, you're not going to find that out until it runs, which can be a little annoying because you may not actually look at the logs right away, and then you come back an hour and a half later going, wait, why did this fail? This can also do validation of build packs, which when you're writing custom build packs is quite handy. And it will, because I have another strange little obsession with validation error messages, if you've used declarative and how it just insists on pointing exactly where the error was, we try to do the same thing here where we're pointing to where in the YAML the error is so that you can say, oh, that's what I did wrong, here's what I need to fix. If you're using inheritance, if you're using build packs, if you're using default pipelines, what's represented in your Jenkins X YAML is not explicitly what's going to run. You may want to actually be able to look at it and say, what's actually going to happen here? So inspired directly by Maven's effective POM command, we have jx step syntax effective. It reads your Jenkins X YAML or build pack, et cetera, figures out what the actual effective pipeline will be that will get executed, and prints out basically a Jenkins X YAML with that effective pipeline. We actually use this in pipeline, in how we parse and create the pipeline. We run the same thing as the validate and the same thing as generating the effective pipeline, and then translate that into what's necessary to actually run it in Tecton. So it's just a handy little thing to see what the magic is actually doing, to be able to debug why this override isn't doing what you thought it is, and you can take a look and see where it's actually ending up, what's actually being changed by your configuration. Now this one I love. This one kind of came about as an accident, as part of the validation work. I realized, we should have a schema for this. That'll make validation easier, so I'm not just, so that if there's an issue with parsing the YAML, not just whether it's valid for what we care about, whether you have the right flag set, the right fields, if it's just parsable, we should have a schema for the JSON syntax, for the YAML syntax, which is just a JSON schema. Then it turns out that when you have a JSON schema registered on schemastore.org, you get autocomplete and syntax highlighting automatically in IntelliJ. with assuming you have the YAML plugin installed. And that if you install the YAML language extension in VS Code, you get that there too. I thought that was like, yeah, black magic. It was just like, wait, what? Why did suddenly, when I wasn't looking, it started telling me that that was invalid when I was adding new syntax, but it wasn't complaining about the old syntax? What just happened here? How is it reading my mind? So yeah, I literally discovered that happened by accident, and it was just like, oh. So I'm not a huge fan of YAML. I don't like white space being significant. Sorry, Python people. I really aesthetically like, I like Lisp, but I like the declarative syntax quite a bit. But I think that the ease of IDE integration and autocomplete and validation that you get with YAML for this kind of thing probably makes it worth it. So it's something I'm really happy about, and I think is really useful when you're authoring pipelines. So yeah, the future is being written here. We're still getting started. You can help. This is the best baby robot picture I could find online. I probably should have blurred out the Toyota logo though. Yeah, Toyota apparently makes baby robots now. I'm not really sure what's going on there. But it's a cute little baby robot, so. So yeah, Jenkins X Pipeline is very young. Jenkins X itself is only around 1.5 years old. The serverless Jenkins X pipelines have only been around for 6 or 7 months. The Tecton project that our execution is based on has only been around since September of last year. That means that there's a lot that's still to come, that we're still evolving, figuring out what we need to do, what you need that we don't support currently. We're able to power the standard Jenkins X build pack pipelines out of the box. That was our minimum set of functionality we needed to be able to move from static masters to Jenkins X pipeline without losing any features, any functionality. But there's more that seems like it would be useful. Conditional execution of stages, saying, don't run these steps if I'm not on a certain branch, or if it's daytime for some reason, I don't know. Jenkins X apps, which is the way to extend Jenkins X, will be able to automatically inject steps and stages into your pipelines so that you can say, I need to make sure all pipelines in my organization are running a security scan, that they have to. This is not something I want to trust that my users will actually configure. So we know when we want that to happen. Let's make sure that always happens. So the Jenkins X apps will be able to do that. You'll be able to specify, here are the steps or stages I want added, and then it will just happen automatically for every pipeline that gets executed in your organization. We're looking at more advanced configuration for stage pods, better work around timeout, retry, and the like. Post equivalent from declarative to say, after the build run, after this stage or pipeline finishes, depending on what the result is, whatever, maybe send a notification, tear down a cluster, et cetera. And more solutions and functionality around pipeline and stage sharing across repositories beyond just build packs and copy paste. So if you want to play with this, if you end up needing help, the first place to look is always Slack. We've got Slack, it's got a link on the Jenkins XIO community page, and there's always somebody there. Me too often, but not just me. We've got documentation that is not yet perfect because it's documentation, and I wrote a good chunk of it, which means it's really not perfect. But we've got a pipeline syntax reference, we've got some examples, we've got more that are coming, and we're hoping to keep that all up to date. And of course, Jenkins X itself is in GitHub, and you can look at the source, et cetera. Now, I should mention, because otherwise leadership at CloudBees might taser me, that CloudBees does offer Jenkins X support and the CloudBees Jenkins X distribution. So if you're interested in that, You can download the distribution. It's a curated version where we're controlling the versions. You're not necessarily going to get the bleeding edge latest, but honestly, I have a fear of running bleeding edge latest of anything, so I like running stuff that we know has been through some validation and testing first, additional testing. Not implying that Jenkins X is untested. Do not take that interpretation. It is tested. But testing the interoperability of everything, and when we've got constant releases going whenever there's a new commit, because that's how Jenkins X wants you to work, things might not be the best at any given moment in time. So we try to curate that for you. And of course, commercial support is always a useful thing. And in addition, there's lots of other cloud-based stuff. I also was forced to put this slide in. But I'm sure you've heard about a fair number of these. I'm not actually going to talk about any of them. Because we only got a few minutes left for questions. So thank you very much. And questions? Yes?
So if I run JX import to migrate some existing project, what really happens? My second question
Yeah.
is, how do you map Jenkins X stage steps to Tecton and steps?
All right, so the first question was what exactly happens when you run JX import to pull in a new project? And honestly, I'm not the best person to answer that. So I'm going to cheat and ignore it. There's a talk at, I believe, 1:15 today, or maybe it's a little later, by James Rawlings. It'll go into a lot more detail of the mechanics of Jenkins X beyond just pipeline that may be of interest. In terms of how, the second question was how the Jenkins X pipeline concepts of stages and steps map to Tecton's internal concepts of tasks and steps directly. A stage is a task, a stage that has steps in it translates to a Tecton task. The reason that we're not using that directly is that we also wanted to have nested stages and the ability to inherit configuration and have our own curated syntax. Tecton syntax is very verbose and explicit, which is a really good thing. I think of it as kind of the machine code, the intermediate representation. It's really great for being able to say, this is exactly what's going to happen. Everything is explicitly specified. There's no guessing or implicitness. There's no magic. But for something that's actually authored by humans, magic is kind of nice. Implicit behavior is pretty handy, and it allows us to build logic on top of Tekton to better serve what we want to achieve with Jenkins X pipelines. I mean, I love Tecton. I'm not in any way saying anything bad about Tecton. I would never, because I'm on the governance board, so it'd be very, very impolite of me. But yeah, we think there's a real value in providing a layer above that at the pipeline syntax level, not just in terms of the overall workflow and behavior of Jenkins X. But in the end, yeah, it translates to a task. Yes? The question is a UI coming to Jenkins X? The answer is yes. I don't know exactly when. Nobody lets me work on UI because it always comes out really badly and typically looks like it comes from 1997. I like the blink tag too much. But it is churning along. I don't think we have a specific date, but it will be available in the non-distant-ish future. There will be a UI, yes. But Jenkins X will always be primarily driven by its command line. The UI will not be like Jenkins UI, which is the main way you drive Jenkins. Jenkins starts at the web app UI side, and any CLI support is an add-on, or feels always a little stapled onto the side. Whereas Jenkins X is the opposite approach, where it's the command line first, and then the UI is a second thought. Anybody else? All right, well, thank you all very much. Enjoy the rest of the conference, and I'll see you all later.